Hi, my name is Linda Sofia Martinez Jimenez, and what I can conclude from this experiment is that it's really interesting to see how charges works and to see that we can charge an object by just rubbing it with another or by contact or by induction. And especially what I found really interesting was how the result of the experiment of the can and the balloon, because it was just like the first we charged the balloon with by rubbing it with my hair, and it acquires a negative charge, and then the can had like a neutral charge. um, it means it has positive and negative charge, and when we put the balloon close to the can, it the balloon repelled the negative charges from the can, so it was just like a part of the can with positive charge, and those charges, the negative charges of the balloon and the positive charges of the can, were attracted, despite the can has a neutral charge. So it was really interesting and to see it, and also it's like really interesting and also important to know how charges works, to um to like we can be aware from being electrified, for example. And it also was like um not like funny but interesting, the experiment of the ring, because um it was supposed to levitate, like the strip of the plastic bag. It was supposed to levitate, but it was because of how the charges acted, because they were both charged with a negative charge. And when we put like the balloon and also the strip of the plastic bag together, they were repelled. So it was like simulating like it was floating or levitating, but it was just the action of the charges in both objects. So it was really, this exercise was really interesting.
Hi, my name is Pamela, and my conclusion is that with this experiment, we were able to check and see how it worked Coulomb's law of electrostatics. Um, that this can explain the force experienced by two electrical charges at rest, and this law can predict what will be the electrostatic force of attraction or repulsion between two particles according to their electrical charge and the distance between them. Thank you.
Hi, my name is Sofia Molina Padilla, and I was the theoretical researcher. And I found interesting to see in experiments that if they are equal charges, they really move away from each other, as well as the can and the balloon. That when I put the static with the hair or sweater, it was charged and made it move away from the can. I like this topic, but it was a little complicated with the diagrams to understand the chargers and where each one goes. But I think it helped me to understand more with this activity and the help of my classmates.
Hi, I'm Irvin Gerardo Zamarron Hernandez, and this is my conclusion about the exercise 7 for the subject of matter and energy 2. So, for this practice, it was not very necessary to anticipate the planning as well as the elaboration of experiments, because they were simpler and only one required to do it with materials. And two of them were simulated on a platform on internet. So from the one that was done with materials, it was possible to observe what we saw in topic 6 with the types of charge and how they interact with each other. So in this case, it happened that the balloon acquired a negative charge and that interact with the neutral charge of the can, so making them to go to one side um, where the balloon was directed. So I think the main thing was to keep observing and calculating the interactions between the charge. And then, as a team leader, I had to recognize um, that resilience was part of this practice because in the previous one, I had many activities that did not allow me to be very aware of the follow up or elaboration um, for that practice. So, um, however, I left the assigned activities and a person in charge to follow up, and knowing that nothing was really done, uh, that bothered me, and well, but this time we talk about it and resolve it, and that was how we were able to do it successfully. Out of there, my tasks are still be marking times or setting the pattern of how we are we are going to work, and give the necessary tools to carry out the practice as well as support to any member who requires it. So this time I only made a change between the roles because one of the members was not present when the topics were given. So I could not I sorry, there are persons here, but she could not solve the calculations on the problem so easily. So those who were solving all the calculations, which were two people, had to be left alone, and the person in question had to support the realization of the experiments, especially those that were carried out in the simulator to make them easier to understand. And apart from that, this practice was definitely a quick one with good results.
Hi, I'm Maximiliano Salazar Alvarez, and I'm filming my conclusion of the exercise 7 of Matter and Energy 2. At first, I will explain that I was the video maker, so I was the one in charge of filming all the videos. Well, not in charge, but I'm the one who will make all that videos together in one, so it's easier to see. So that I think that doesn't explain much about the topic, so I will talk about it. I think it's kind of interesting to see about this um exercise, because in this exercise we saw that the parts of like the electrostatics, yeah, all about that, the neutrons, the and all that thing kind of stuff. Like for example, that the positives and the negatives they attract each one, and if they are the same, for example, a positive and a positive one, they repel themselves. So I think with that information, it's easier to explain what we did in the exercise. At first, let's talk about what we did in the experiments. In one of the experiments, it's like kind of fun because this is one like you did in the first school. So first one, we just take a balloon and we make it friction with our clothes or with our hair. With that we can charge the balloon with the electrons, and with that we are making it like induction. We are making the balloon to get positive and negative electrons or protons, I don't know very well. But with that we can say that also with the plastic strip we put like also do the same like as we did with the balloon. With that we create a like something that doesn't, they start to repel themselves. And with that, it's like the first experiment to say it. And with the second one, it's like the same, but we only make friction with our clothes or the hair with the balloon, and the bottle can of metal, I don't know. It's just like living up there, and with that, it's just like we get closer the balloon to the can, and with that, the can starts to repel because of the neutral neutrons, and with that, it's like what we made. We start to see about the electrons, about if they attract or they repel, and that's all for my part. Thanks.
Hi, I'm Luis Eduardo Martinez Ramirez from the 602 group, and this is my conclusion of the exercise number 7. Physics is everywhere. Even when you don't notice it, it is there. In this case, I'm going to talk about the electrostatic. When you rub a balloon in a sweater, it actually is electrostatic. The balloon absorbs the electrons of the sweater and leaves it with a positive charge. And as we know, opposite charges attract each other. And that's why the balloon sticks to it and it doesn't go away. In the case that we take the balloon and put it near a neutrally charged object or thing, it will repel the object's electrons because those have the same charge as the balloon. And as we also know, objects that have the same electric charge will repel each other. Actually, this is explained in the Coulomb's law. This states that the force of attraction or repulsion acting along a straight line between two electric charges is directly proportional to the product of the charges and inversely to the square of the distance between them. That can be expressed in a formula that we use to calculate the electrostatic force between charges. We see if they attract or repel each other. It can be written as F equals to K times absolute value of charges 1 and 2 over the radius to the square. In my opinion, I think that we should know at least a little about how the world works. In this case, in the physics point of view. Because if we understand it, it can be our ally when we need it. And a bit of knowledge and information doesn't hurt anyone, right? I also think that the charges and the electrostatic play a really important role in like everyday life, because physics is an important part of everything about how the world works, but that specifically, it's an important part of it. Like, it composes a really important part of life. It can affect the work of someone, or, well, in this case, like in the example, with the balloon sweater, it's actually in every day. So, as a conclusion, I think it's really important to know about this.